Hi there. So this question is also quite tricky. The longest diagonal of a regular hexagon are 12 centimeter. How many smaller regular hexagons with longest diagonal 6, which is half of this, can fit into larger hexagon with no overlapping? Yeah. So let's say there is a larger hexagon. I'll try to make it as regular as I can, but with freehand. So apologies if it is not. Let's say this is suppose this is a regular hexagon. Now you should know the largest diagonal is the one which is joined by vertex, which is exactly opposite. So if I join all of the largest diagonals, you will notice that this shape gets divided into 6 equilateral triangles, because this is 120. Yeah, inside interior angle of hexagon, you're joining with the center, you're splitting the side equally. So 60, 60, 60, 60, and so on, which means also in the center, you're dividing that into 6 equal parts. They're all same due to symmetry. So 360 by 6. In the center also, you're getting 60. So this has to be equilateral triangle inside. So this is a property actually that you can remember, that a hexagon, when you join all the opposite vertices to make the longest diagonals, you actually divide the hexagon into 6 equilateral triangles. They are all equal. But what does that mean? That means that if this side of the hexagon is x, then this has to be x, because this is also the similar equilateral triangle. And this has to be x as well, which means the size of the longest diagonal in a hexagon is double the size of the side of the hexagon itself. And so if I have a smaller hexagon to be fitted inside, whose longest side is half of this, which means this is also x, because this is 6 centimeter and this is 12 centimeter, right? So this is 12, so this is 6. How many of such I can fit inside? That is the question, right? So let's see. I remove this x and x and I change to a different color. Yeah. The one way to do that will be, because if the longest diagonal is half of this, then the side also has to be half of this. So the side is x by 2, which means I have to split somewhere here. So if I split the side into half, I split this side into half. So I have got 2 sides of a hexagon. If I go up here parallelly, yeah, I'll get the third side. This becomes my fourth side. This is already in the longer diagonal. I have the fifth side. If I go in the middle position, I'll get my first hexagon, which is this hexagon, right? Now I've got my one hexagon. Yeah. Here I can't, can I do anything about it? Maybe. So if this is going to be one side and this is going to be second side, now this is creating such some shape like a diamond, right? So maybe not here. Can I create something here then? Let's see. So if it's this side, this hexagon, see, if I take it parallelly to the diagonal to get the third side, then I find myself, because of symmetry, this is also split half and half here. Yeah. And then similarly, half and half here. I got my second hexagon fitted and I still have some space left here. Let's see if I can utilize this space. So if I split it half, where like here, and go parallel to join here, I split into half here, I come here, I join here, and see, I got the third one here. Look, which means I got one hexagon, I've got two hexagon, I've got three hexagon fitted by joining the points here. Yeah. Okay. So I hope that was clear. And we will see the next question then. So the next question, I think that is very easy. So in this problem, they say there is this type of diagram where you have a big rectangular shape A, you have a smaller rectangular shape B. They have given some dimensions. So this is y centimeter long. This is not Z, the Z is overall. And that means the width of this triangle rectangle is Y, oh sorry, not Y, this Z minus this. So Z minus this. If you remove this part, you will be left with this part. So Z minus W. And that means the area of this shape should be Y multiplied by Z minus W. So if they are saying you give the ratio of area of shape A to area of shape B, area of shape A is Y times Z minus W, which is not this. This I can park, this I can park, not this and not this. Now shape B, shape is clearly W and X, two dimensions. So area of shape B is W times X. It could be X times W, whichever. And I can see in one of my remaining options, I have W and X, which means this is same. So area of this is to area of this is same as Y times Z minus W, which is area of shape A, and WX, which is area of shape B. So this C is my answer, correct? So that's all for the day today. Thank you very much.